Okay, so before I start the class, so this morning I just posted something in your general channel. Okay, so this is about the events that, okay, students, can you see my screen right now? I'm in your general channel.
Yes, we can.
Yes, Miss, can see.
Okay, thank you. Okay, so this morning I just posted some things about the Maths Festival. Okay, Festival is actually the annual event organized by my school, School of Mathematics, Actuarial Studies, and Actuarial and Quantitative Studies. Okay, so we will. This is our annual major event. So from the words, from the title of the event, you already know that it is about maths. Okay, so since it's by School of Mathematics, okay, so Maths Festival will be held on a whole week. Okay, it's a weekly, it's a 1 week event. It's not a 1 day event. So it's happen on 20th to 24th September. Okay, and by looking at this, right, I put some details about the games in the post. You can have a look. Okay, so during this week we will have various maths competition. Okay, various types of the games, and to participate to the game is actually FOC. You don't need to give any registration fees. Okay, so these are the few games, okay, that listed out here. For your information, I'm actually in charge of maths competition, the item 7. And the maths competition that I in charge, of course, I have a students committee. So it's actually the only individual game. Okay, this is the only individual game. That means, okay, the rest you need to participate with team. Okay. So you can ask your friends from your class to actually form a team and then join the games. Okay, so by looking at the name, okay, of course Sudoku, I think you will know what is Sudoku, but I think most others games you may not really know how to play it. Then there is, you can actually click the link of the registration form. So I share the link of the registration form. You can click the link, then when you access to the registration form, you can see the description of the game. So you can actually see what is the description about the games. And then if you think you have an interest, then you can join. Then for your information, if you want to know more details, when you click the link, you can see the lecturers in charge. So you can actually contact with the lecturers if you want to know more. Okay, for my games, if you want to know more, you can also ask me. Okay, and okay, for your information, you can actually visit this, okay, the Instagram, okay, to know about the games. Okay, so, and there are some prizes. Okay, there are prizes for the game as well. But the registration, the entrance to the game is actually free. Okay, so you know, this is an event only organized once a year. So, and I know some students, they really have a great interest in mathematics. So you can have a look, okay, the description, and then just ask your friends to join, to form a team and join. But for maths competition, this is individual game. You can just join. If you have interest, you can just join. Okay. Okay, so yep, okay, this is about the game. Then back to our class. Okay, let me continue with the tutorial question. Last week, because of the holiday, we only have one class and we go through the tutorial questions, but we haven't finished it. And previous class, we stopped at the cosine rule, okay, sine rule, cosine rule, and the area of the triangle, and so on, right? Okay, so today we will continue the discussions of the tutorial. And there's a previous class, I stopped at 11. I asked some students to share some of the solutions from questions 11. Then there's a request to discuss 17 and 18. I will discuss it later. So for the rest of the questions like 13, 14, 15, 16, they already have the graph. They already show you the figure, okay, to about the scenario, about the problem. So it will be easier for you to actually solve the question, right? But I would like to see the solution from the students. But as I say, there are multiple ways to solve it for some of the question, right? Can I have some one or two few students to actually share the solution, right? For questions number 12, 12A, can I have any volunteer before I call the name? If let's say no volunteer, then I will call, okay? So any volunteer for 12A. So I also want the volunteer for questions 13, 14, 15, and 16. I want students to post a solution by one of the different students. 12A, any volunteer? You can raise your hand. No volunteer, then I will just call the name. Okay, so Kritakon, thank you. So Kritakon volunteer for 12A. Then please post the photo of your solution for 12A. Then Kritakon is 12A. Okay, then can I have another for questions 13? 12B, I leave it to you unless you have a problem. Okay, 13. Okay, about question 13. Anyone, you can raise your hand or you want to put in the chat box. Question 13. Any volunteer? Just I saw a name volunteer for questions 12, is it? Okay. 13, how about 13? Any volunteer? Okay, then I will just ask the students. Okay, so I think that day we asking questions from the top. So now I'm asking from the center. Okay, Wei Huan, how about 13? Have you done 13? Kritakon, you can proceed to post your solution already. You don't need to wait. Wei Huan, can you? Okay, yes. Wei Huan for questions 13. Okay, then Man Heng, can you do 14? Do you have a solution for 14? Man Heng, do you have a solution for 14? Yes, okay, post a solution for 14. Muhammad Saad, how about 15? Have you done 15? Previously, I already give the answer, so you should check your answer already. Muhammad Saad, how about,
Miss,
how about 15?
I'm facing a little bit difficulty in 15. I'm still confused.
Okay, so you're not sure about 15. Okay, Sutesh, you want to volunteer for 15? Is it?
Yes, yes.
Can. Okay, thank you. Sutesh for 15. One more question, 16. Ziyi, how about Ziyi? Is that okay? For 16? Yes, okay. So, yeah, okay, thank you, Ziyi, for 16. Okay, for those students are volunteer to post a photo, you can start to post it now. So I saw the first solution from Kritakon. So for questions 12A, okay, so the reason because previously when I asked students say that they have a problem on 17, 18, request me to discuss that. So the rest, I assume you have no problem, but I want to see some of the sample solution. And for others, you can also check your solution. So now let me see the solution from Kritakon. Okay. For okay, I assume is this part. Okay, the rest I'm waiting for your solution. Okay, let us have a look with the solutions from Kritakon. So these questions 12, right? Use the cosine and sine rule to solve the triangles and find their areas. Okay, so this is a triangle with angle A given as 45, B as 55, and the small letter of B is referring to the length of the side B. Okay, so make sure you label it properly. Okay, so I think we can see what is actually drawn by Criticon. But let us have a look. Okay, okay, let us have a look with the triangle. Okay, so let's say we have A, B, and C, right? So the opposite of the angle A, small letter of A. So opposite of the angle B is a small letter of B, which is given as 6 cm. Then this is a side C. Okay, angle A given as 45 degree, angles B as 55. Okay, so they ask you to solve the triangle and find their area. So you need to get the all the angles, all the missing angles and the missing sides, right? So can you see we already have two angles? So that means is we can easily find this angle, angle C, okay? So instead of put X, actually we can put it as a angle C, okay? Angle C. So angle C is very easy. Just take 180 minus 55 minus 45 degree. So you get 80. Okay, so correct. Okay, then we need to find another two sides, which is A and also C, right? Okay, to find the side of the A and side of the C, okay, let's say finding the side A first. Okay, so to find side A, we can use sine rule. Okay, because can you see side A, the corresponding angle is 45. Then we have another side with which is B with the angle of 55, angle B, so we can using sine rule. Okay, so here using sine rule to solve it. So A over sine 45, yes. 6 over sine 55, correct. So we can solve for A equals to 5.18. Okay, let me confirm again. Okay. Okay, yeah. Correct. Okay, 5.18. Okay, so next one. Uh, 8. Okay, wait. There's another side that is missing. Okay, so since we say solve the triangle, as I said, we need to solve the missing part. Okay, the missing sides and also the angle. We got the angle. We got one side. We still need another side of C. Do I miss out anything just now? No.
No, Miss, I forgot to put it in, Miss. Yeah.
Oh, okay, then it's okay. Then I will just add in. Okay, so for side C, okay, so for C, right? Okay, you can using the sine rule as well. Okay, so that means side C divided by sine C equals to maybe B divided by sine B. Okay, so the C is actually the angle, sorry, the side C, which is what we want to find, and the angle of the C, we just found it as 80. Then the side B is 6, the angle is 55, okay? So we can get the answer as 7.21, okay? cm, okay? 7.21 cm. Okay, now let's proceed for the next question. Okay, so for question 13, okay, wave 1 is 13. Okay, I can't just open. Okay, can. Okay, 13 very neat workings. Okay, so for these questions, right? Okay, the figure already given, the weight is supported by the cables attached to both ends of P and Q. So then determines the angles PQO and OPQ. So that means you need to find the angles of P and angle for Q. Okay, between the beam and the cables. Okay, so you need to determine this angle. And for your information, the length of these three sides are given, 90, 45, and 60, right? Okay, so can you see, okay, if you want to get any of the angle, either angle of P and Q, since this one is involved not a right triangle, so we can choose either using the sine rule or cosine rule. But if we want to find one angle, okay, with the sine rule, that means we need another angle and another two sides. So which is not possible because we don't have any of the angle of the triangle. So we have to use the cosine rule. So you can see he's using cosine rule over here, all right? So, okay, first we find the angle for Q, okay, Q. So to find the angle of the Q, can you see how we label the side? So here is small q, small letter of Q equals to 45. Here is P equals to 60 and here is O equals to 90. Okay, that's how we label them. Okay, Q equals to 45 here. Okay, so now for the angle Q, the corresponding side is the 45. Right? So which is 45 square and equals to the square for another two sides, 60 square plus 90 square minus 2 times 90 times 60 times 90, then cos of the OQP, which is the angle that we want to find. Okay, so the next thing is we need to solve this. You can substitute and then you solve it. Okay, so by solving this, okay, 45, okay, 60 square plus 90 square minus 45. So we have 9675, correct? Then 2 times 60 times 90, 10880, correct? Okay, then we solve it. And we get 0.8958, correct? Okay, add cos 26.3843, correct? Okay, so we get the angle. So this is the angle for OQ. Okay, PQO or OQP is the same. Okay, then next one is another angle. Okay, so for another angle here, okay, for this angle, he's using the cosine rule. Okay, correct. So we can use cosine rule to solve it. Okay, so which is the angle P? This is the angle P, corresponding side for angle P, which is 60. Okay, 60 square equals to 45 square plus 90 square minus 2 times 45 times 90 times cos of the angles of OPQ. Right? Okay, so then solve this. 45 square plus 90 square minus 60 square. Okay, 6525. Then 2 times 45 times 90, 8100, correct? Then 6525 divided by 8100, 0.8055, and the angle is 36.33. Yes, correct. Okay? Yeah, this is correct. Okay, so students, okay, if this part, to find the angle of P, right? If I don't want to use cosine rule, can I use sine rule, students? Can I use sine rule?
Yes, can.
Can, okay. We can also use sine rule for this part. Okay, if you're using sine rule for this part, that means it can, because we already got an angle in the earlier part. Okay, so that means to to find the angle of the P. So sine P over 60 equals to sine Q, okay, Q which is obtained as 26.38 divided by the corresponding side which is 45. So we can also find P from here, okay? Okay, so this is another alternate way, okay? Okay, so next one, let's move on to question 14. Okay, if you have any questions, you can ask me. Huh? Okay, so next 14. Huh? Okay, so for questions 14, to measure the distance through a mountain for proposed tunnel, a point C is chosen that can be reached from each end of the tunnel. So end of the tunnel they are A and also B. So these are the two end of the tunnel. So the tunnels is here. Okay, the tunnels is here. Okay, then it will, the point C is here, right? With the distance given AC is 3800 and BC is 2900. Okay, then the angle of the C is actually 110. So determine the length of the tunnel. Okay, so okay, so for this case, right, we can't using sine rule because you need to find the length. So you need, if using sine rule, you need two angles and one length. Okay, so since we don't have two angles, so we can use the cosine rule, which is required one angle only. So here, using cosine rule. Okay, so for cosine rule, to get the tunnel, the length of the tunnel, which is a AB square, so will be equals to the square of another two sides, 3,800 square plus 2,900 square. Okay, so correct. Then minus 2 times 3,800 times 2,900 cos 110. So 110 is the angle corresponding to the length of the tunnel AB. So cos 110. Okay, by solving this one, okay, so AB square, you get this answer, and then you need to find the square root to reach to this answer. Okay, so let me see, 14, okay, the length 5512.54, yes, correct, okay. So to solve this, then you get the length already, okay. Okay, so far, is that clear for other students? Is that clear for other students? Yes,
Yeah, clear, miss.
Okay, thank you. Then for questions 14 done, 15. Okay, questions 15. Do I miss up? Oh, yeah. Okay, so this is a diagram, and so this is 15, right? Do I ask anybody to do 15? Huh?
Yes, that one.
Oh, okay. Sorry. Thank you.
It's fine.
Okay, so this is a solution for questions 15. So a reciprocating engine mechanism is shown in the figure. So the crank of AB. So AB is a crank, huh? Okay, so here is the crank AB. Okay, then it's 12 cm. Then long, and the connecting rod for BC. So BC is a rod, connecting rod, and with 32 cm long. For the position shown, determine the length of AC. So you need to find AC. And then the angle between the crank and the rod. So that means this is the angles that you need to find. So you require to find two things here, right? Okay, so for Sutesh, he actually find the angle first. Okay, he find the angle first, huh? Then followed by the he find the angle first. Okay, he find the angle by using the sine rule. Okay, so but to find the angle of the B, you need the length of the C. So he find the angle for C also. Then with the angle of C, he find the angle of B. Okay, so this is also another alternate way. Okay, so to find the angle of the C, using the sine rule, sine C divided by 12 equals to sine 40 divided by the length of 32. Yes, correct. And then from here, he find the angle C. Okay, so okay, 13.95, correct? Okay. Then after that, he just find the angle of B, 180 degree minus 13.95 minus 40. Okay, correct. So the answer is actually 126.05. Yep, correct. Okay, so next is to find the AC. So AC, which is the length of the B, is the same, huh? Okay, B and AC is referring to the same length. Okay, so he using sine rule again because he has an angle and the length of the side. So sine, the corresponding angle with the side B is actually angle B. Huh? So angle B is actually 126.05. We found it just now. And then we can use another angle in another side. So for example, using angle A, so which is sine 40 divided by the corresponding side, which is 32. Okay, then solve it to get B. Okay, so 40.25. Yes, correct. Okay, so 15 is correct. Then we need another one for the questions 16. Okay, for question 16. So when you look at your friends, your classmates, the solution, you realize that, oh, actually, they may show some alternate way. So which is the way that you may really thought about that. So there are more than one way to solve it. Okay, so for question 17, okay, then do we have a solution 16 from, okay, Ziyi? Okay, so this is a solution from Ziyi. Okay, a zip crane is shown in the figure if the tie rod PR is 8 meter long. Okay, so here is 8 meter long. Okay, 8. Okay, then PQ is actually, this is P, this is Q, this is R. Okay, PQ is 4.5, so here is 4.5, right? Bigger. Okay, then determine the length of RQ. So you need to find this length. Okay, you need to find RQ. Let's see how we actually find RQ. Okay, so okay, I know it's a kind of quite small, right? Okay, let me enlarge it. Okay, so, oh, she directly solved it. She's using the cosine rule, okay? So, to get the length for PQ, okay? Okay, so length for PQ, if you're using the cosine rule, then will be, RQ. RQ square equals to the square of another two sides, 8 square plus 4.5 square minus 2 times 8 times 4.5 times cos. Corresponding angle is 130 is given. Okay, so he's actually come from this cosine rule. Then to find RQ with the square root. So she used a square root here, okay, to get the answer. So which is 11.4. Okay, 11.2. Wait. I get 11.43. Okay, is it because of the rounding error? If you're using calculator to type the whole thing, to insert everything from the equation, you can actually get 11.43. Okay, I'm not sure whether it's due to the calculation error or the rounding error. Okay, Ziyi? Okay, maybe you check again, right? Okay, so next one is the angle between the zip and the tie rod. So the angle between the zip, okay, tie rod is PR. PR is the tie rod. Okay, this one is a tie rod and the zip is a RQ. So this one is a zip. So they say the angle between the zip and the tie rod, that means this angle. Okay, so this is an angle. Okay, so to find this angle, she using the sine rule, right? Okay. So sine R divided by the corresponding side 4.5, then sine 130 divided by the length that we found just now, 11.2. So correct. Then we can solve for the sine. For the R then is 17.93. Okay, because of the values he used is different, so will be slightly different with my answer. So because if I'm doing it, then I will divide it by 11.43. Then my answer is actually 17.55, slightly different. Okay, slightly different. Okay, so this is the answer I given last week. Okay. Okay, so that's what they asked. Actually, another angle is not required. Okay, so this one is not required. Okay, so is that clear so far?
Yeah, clear, miss.
Okay, thanks. Okay, so next is about question 17. So for question 17, right? Okay, so let's try to understand the problem first. Okay. Okay, so this is question 17. Let me explain. They involve two ships here. A ship P sails at a steady speed of 45 km per hour in the direction of west 32 degree north from a port. And then at the same time, another ship Q actually leaves the port at a steady speed of 35 km per hour in another direction of north 15 degree east. Determine the distance after 4 hours. Okay, so they give you the bearing, okay, the bearing of the direction, right? So let us have a look, okay, try to understand what is means by this one, right? In this direction. Okay, so if I'm trying to draw this out, okay, so as we know, this is a north, right? Okay, this is a north. Okay, then the east, the west. Okay, so for ship P, right? Okay, so they sails at the direction of west 32 degree north, means we actually measure the angle from west towards the north. So west is actually this direction 32 degree, which is this one. Okay, so this is 32 degrees. So this is referring to the bearing west 32 degree to north. So it's measured from west 32 degree to the north. Okay, and let's say after 4 hours by traveling from here, okay, with the speed given, let's say this one is the position of ship P. Okay, then look at another Q. Q is actually with the direction of north 15 degree east. Then that means you measure from north to east. So let's say this is the direction. So this is the 15 degree from north to the east. Okay, from north to the east. So that's how you measure it. Okay, let's say this is a position of a ship Q after travel for 4 hours. Okay, so this is what we get, okay, according to the question. And please take note, each ship, they have their speed, right? Okay, so then may I know what is the distance is actually being traveled by the each of the ship, right? Okay, so let's start with the ship P. Okay, so ship P is actually sails with 45 km per hour. So what happened? What is the distance travel after 4 hours? Okay, so if let's say this is the speed. Okay, can I have a students to tell me? Okay, okay, Samuel.
Miss, I already posted my solution earlier.
You put your solution. Oh, okay.
Yeah, earlier.
Okay, then doesn't matter. I want the distance travel. Okay, Kaifeng, what is the distance travel?
No, Miss, I mean, I was putting the solution for question 17. Like, the distance travel was 180, if I'm not mistaken. 45
okay, 180,
times
how
4.
you, okay, 45 times 4, correct. Okay, so because 45 km per hour, so 4 hours will be 45 times 4, which is 180 km. Okay, 180 km. So next one is a ship Q. Okay, so again, what is the distance travel? Okay, so so another shape is 35 km per hour. Okay, so that means 35 times 4, which is equals to 140 km. Okay, so we already know the distance. So the distance is 140 here and 180 km here. Okay, so if we draw the complete triangle, okay, so it should be looks like this. So this is P, this is Q, this is 140 km, this is 180 km. Okay, so we know this angle is 15. Okay, but may I know what is this angle? Okay, so it's okay. Can I have another student to answer me this question? Muhammad Saad, can you tell me what is the angles here? Can you able to know what is the angles here?
180 minus 32.
Sorry?
180 minus 32.
Why is 180? Because here is 90 degree, right?
Oh, so ma'am, 90 minus 32.
Yes, 90 minus 32 is what? 58, right? So it's 58 here. So if let's say here is 58, so what is the angle here? $73. Okay, thank you. Okay, so this is the angle. Then we can actually solve for the PQ because you need the distance. You need to find the distance of the two shapes after 4 hours, right? So you need to find this distance. Okay. So since you have one corresponding angle, we're using the cosine rule. So which is a PQ square equals to 180 square plus 140 square plus 2 times 180 times 140. Angle for this one, let's say we put an O, angle O, okay? So we can, the angle O, which is 73 degree, right? Cos 73. Okay, then we solve for this one. Then we can get the square root, which is 193.04. Okay, so is that clear for questions 14? Sorry, 17?
Yeah, clear, miss.
Clear? Okay,
Clear, miss.
so,
Thank you.
okay. Okay, so for questions 18, right? Okay. Okay, just now the students say you already posed a solution for 18. Okay, so let us have a look since there's a student's post a solution. Okay, so let us have a look. Two sides of a triangular plot of length are 52 and 43 meter respectively. So they say two sides of a triangle. So that means if I draw it up, one of the side, let's say I label it as a ABC. One side is 52, the other side is 43. And if the area is actually 1050.6, area of the triangle is actually 1050.6. Okay, then determine A, the length of the fencing required to enclose the plot, and B, the three angles of the triangular prod. Okay, so for part A, you need to find the fencing to enclose the prod. So you already, for the triangle, you already have two sides. So you just need another side for BC. So you can know what is the fence, what is the length of the fencing, right? You need to total up all the three sides, the length of the three sides. So you need BC, yeah? Okay, so in order to find the length of the BC, so we can actually use the cosine rule, but we need one angle, okay? We need one of the angle. So if I want to find BC, then I need the angle of the A, right? So to find BC by using cosine rule, then I need the angle for A. So to get the angles of the A, okay, A is not provided, but they give you the area, okay? They give you the area. So to find the area, so still remember the way we find the area, okay? So it's actually 1/2 times the two side, then multiply with the sine of the angle, okay? So if I want the angle of the A, okay, so A should be the included angle of the two sides of AB and AC. So this one will be 52 and 43. The angle must be the included angle, the angle between the two sides, okay, that we use for the calculation. So 1050.6, right? So from here, we try to solve for the A, right? So okay, so 52/2 is actually 26. 26 times 43 is actually 1118 times sine A equals to 1050.6. So 1050.6 divided by 1118. Then you proceed to find A, the arc sine, okay? So your A should be exactly 70 degree. Yep. Okay, so we can manage to find 70 degree. Okay, so I didn't show the very details working. Okay, so once we get the angle of 70 degree, okay, then that means A is 70 here. Then we can find the length of the BC, right? Okay, by using the cosine rule. Okay, so here he's directly using the square root. Okay, so that means BC square is actually equals to 52 square plus 43 square minus 2 times 52 times 43 times cos 70. Okay, so then to find the square root BC, so this one is the BC, okay, square root, then you need to find the square root. Okay, then your answer will be 55. Yeah, I get 54.99. Yeah, around 55. Okay, so he get 55. Okay, almost the same answer. Okay, so then the fencing, okay, you should not stop it here because they say the fencing means the length of the fencing. You must total up all the three sides. So which is 52 plus 43 plus 54.99. So you get the totals of 149.99. Okay, so it's approximately 150. Yeah. Okay, so done. This is the fencing. Okay, so next one, to get the three angles of the triangular prod. So we already have one angle. So another one angle you can find by using sine rule. Okay, so by looking at the solution here, okay, so he used sine 70 divided by 55. This one he got 55. Then sine B divided by, sine C, okay, so this one can put it as a sine C. Okay, sine C divided by 52, sine C divided by 52, correct? Okay, then you can solve for the C and you get 62.68. Okay, okay, so about the same. Then for another angle, so this one found as a 62 point something, right? Okay, slightly different with my answer. Okay, then you can able to find C. 180 minus 62.68 minus 70, then you get 47.22. Yes, correct. Okay, so done for the question 17 and 18. So 19 and 20 is actually quite easy, right? Okay, do I share my answers already? 19 and 20, students?
Share already, Miss.
Sure already, right? Okay.
Yeah.
So, okay, thank you. So, for 19 and 20, okay, so I just need one solution for 19 and one solution for 20. So, because this one is an easy question. So, can I have 19A from students? Okay. Can I have, okay, Jing Yan? Can you give me the questions for 19A? Jing Yan? Yes, okay. So for 20A, Benny? Do you have a solution for 20A, Benny?
Not yet. Maybe I do it right now.
Oh, okay, not yet. Okay, then it's okay. I call others. Excel? Ling Hua Jie? Ling Hua Jia? How about Excel? 20A? Yes, okay, so show your solution. So after these two questions, then I will give you a short break. Then we can continue our lecture, okay? These two are the simple one. So I just want to see the solution. Very simple solution. I think even you type in the chat box also can, right? Okay, doesn't matter.
Excuse me, ma'am, I have a question.
Yes, Muhammad Saad, yes?
Ma'am, in quiz, we will be having quiz. So in quiz, we have difficult question like this or easy one?
Sorry, I can't hear you.
Ma'am, you can hear me now?
Yes.
So ma'am, my question is that in quiz, we will be having tricky questions or the easy questions?
Okay, so for any assessment, suppose they are the so-called easy, moderate, and tough question, it should be quite equally distributed. So in any of the assessments, so we have some easy question, moderate, and some difficult questions. Suppose normally, okay. So that's how we actually set the question. Yes. And sometimes I don't know, some students, they always think their assessment paper is the tougher. Okay. Okay. For future revision, I may go through the, previously I actually shared the sample quizzes in the Moodle. So, but that is for quizzes, not the new assessment. But anyway, because your first test will cover trigonometry, so the first two quizzes actually is about trigonometry. So the questions I will also use the same questions to actually do revision review, or maybe sometimes I will add a few more questions. Okay. And yeah, I think these times, because this is a first, okay, I know you all have done EMTS. You should be familiar with your submission, but for your information, for my assessment, I required PDF file only. I know last time for EMTS, your lecturers do not require PDF file only. They can accept other types of the file. But because previously I have an issue, those students who submit other types of the file, I have an issue to open it in the Moodle for the marking. So, and it gave me a lot of the issue. many students who submit with the words file, and I can't able to open. So if you can compile in the words file, then I think the next step, you can easily convert it to PDF file. So if any one of you still don't know how to convert to PDF file, please try to find out, okay? I think before come to the real quiz, I will have a mock quiz. And for your quiz of, before the real test, I want to have a mock test. So for the mock test, I will, how to say, I will only allow PDF file submission. So when come to the real assessment, also only PDF file submission. So you need to figure out if, let's say, you don't know how to do it. Okay, so I think we have the solutions from students already, is it? Okay. So this one is for, okay, 19A. Okay, so okay, so these two are the simple one. Okay, so this one is for the degree. Okay, so okay, remember this formula is already provided, okay, in your slide, okay? So to convert degree to radian, so you just need to take the degree and divide it by 180 degree, because 1 pi is actually equals to 180. Then you multiply by pi, okay? So sometimes we will have our angle in the radian, which is given as pi radian, or sometimes we don't have a pi, we just have a numbers followed by radian, only radian, but sometimes we put as pi radian. So here, you calculate as a radian, okay? So this is the answer. Okay, the method is correct. So the other one is from the radian convert to degree. So radian convert to degree, so the radian will be divided by pi and then multiply by 180 degree. So 2.45 times 180 divided by pi. Okay, so then you get 140.36. I try to write slightly bigger. Okay, so this is your solution. Okay, okay, is there any questions before I give you a short break? Is there any question before I giving you short?
No question, miss. All clear.
Okay, okay, so I will give you a 10 minutes break. Okay, then after 10 minutes break, then I will continue with the lecture. Okay, take the attendance, then continue with the lecture. Okay, 10 minutes break. By the way, is it David is here already? He's still not here. It's not joining the class. Okay, doesn't matter. So we will continue for our break. So I put the timer so you know when to come back. Okay, so we continue after 10 minutes. Okay, students, let's continue. Okay, let me take the attendance first. So today, Monday, tutorial T4. Okay, 2:30, 2 hours tutorial. Okay, take your attendance first. Two absent. Okay, so David is not around. Samuel, I thought Samuel is here. Okay, taken already. So one absent, that David. Okay. Okay, so let's continue. Okay. Okay, so what we're going to go through for the next, we will go through some about the trigonometric identities, and then how we find the angles. Okay, how we find the angles. Okay, so let's have a recap. So when we have a right angle triangle, so what is the sine, what is the cos, what is the tangent? So by referring to this triangle, okay, let me just a quick one, okay, sine A, cos A, tangent A. Then what is a cosecant, which is 1 over sine, secant, which is 1 over cos, cotangent, which is 1 over tangent. And remember tangent, the relationship with the sine and cos is sine over cos. And then cotangent will be cos over sine. Okay, just a quick one. This one we have gone through earlier. Okay, now, there are some trigonometric identities that you should have gone through during your high school earlier. Okay, so how we actually get to these trigonometric identities, just to give you some ideas. So the three basic trigonometric identities that most of us are quite, it's quite common. These identities are quite commonly used. So for example, the sine square A plus cos square A. So this is a very basic one. And 1 plus cotangent square A is actually equals to cosecant square. And 1 plus tangent square equals to secant square A. So these are three basic trigonometric identities. And how we get these three identities is actually come from the by applying Pythagoras theorem. So looking at this right angle triangle, okay. So as we know for theorem of Pythagoras, C is the hypotenuse, right? Then A square plus B square is actually equals to C square, okay. So this is a theorem. Then if I take the equation, okay, and divide it by c squared, so the whole equation divided by c squared, then I will have a squared over c squared plus b squared over c squared. So a over c, right? Okay, this a over c is actually equals to sine. Okay, a over c is actually sine a. Okay, a over c is actually sine a. Okay, so A over C is actually sine angle A. Okay, so when you have A square over c square, right? It's actually a over c square. So which is equals to sine a square, which is same as sine square a. Okay, so that's how we get the sine square a. The next one is a b square over c square. So b over c is actually cos a. Okay, so b over c is cos a. So b square over c square will be cos square a. Then the right hand side is 1. So using this way, we actually derive the first identities. Okay, and for the rest of the identities is derived by using the same concept. So I don't think I need to explain in details, just give you some ideas. Okay, so the next one, 1 plus cotangent square a equals to cosecant square. A is obtained when we divide the whole equation by a square. And the next one divided by b square, then we will get 1 plus tangent square a equals to secant square a. Okay, okay, so normally we are not too focused on how we derive it, but is how we actually apply the identities. Okay, so of course for these identities, right, as the basic one, we will expect students can remember a little bit, but when come to assessment, we are not assess how well students can memorize the identities. We are assess how students can apply, how well they can apply the identity. So when come to the assessment, right, the identities will be provided. So don't worry about memorizing the identities. You are not required to memorize it. Okay, so now let's move on to compound angle. So this compound angle formula is about the addition or subtraction of the angle for sine and cos and tangent. So try to understand, this formula will be provided, but you need to understand how the formula works, right? So for sine A plus minus B means if there is a plus, okay, the angle of sine A plus B, then the formula will be sine A cos B plus cos A sine B. Okay, so can you see the left hand side we put plus minus, the right hand side we also put plus minus. So if let's say we need to find the sine of angle A plus B, then the formula at the right hand side is also a plus. So if I want to find sine of the A minus B, right, then your formula at the right hand side also involve a minus. So this is means by the formula, because some students, they don't understand the formula. Huh? Okay, now come to the cos. Then you have to take note. Cos is opposite. When you find the cos of A plus B, right, the formula will be cos A cos B minus sine A sine B. Cos A cos B minus sine A sine B. Okay, then for the left hand side, if involve cos A minus B, then the right hand side, the formula will be a plus. So the sign is opposite. Okay, then for tangent, tangent you have to take note. Okay, so if they involve a addition, sine A plus B, right? So the formula of the numerator, the top, you should use a sum. Then for the bottom is a minus. Okay, but if let's say you involve the subtraction, tangent A minus tangent B, then at the top you're using minus, but the bottom you should using the plus. Okay, so can you understand the formula, students? Is that clear so far, the formula? Yes, sir?
Yes, miss.
Okay, thank you for the feedback. Okay, then let's move on to another formula. So this formula, we call it as double angle formula because we involve 2 theta. So that's what we're trying to say, double angle, right? So sine 2 theta, right, is actually equals to 2 sine theta cos theta. So when we express it here, is in single theta, okay? Then for cos 2 theta, right? Okay, when we express as a single theta, then will be, there are 3 possible formula. So the first one will involve both cos and sine. So it's cos square theta minus sine square theta. Then if let's say only involve sine, then will be 1 minus 2 sine square theta. If let's say only involve cos, then will be 2 cos square theta minus 1. Okay, so when to use which formula is depends on the usage, how you want to apply it into solving some of the problems. Okay, so if let's say the problems you just want to convert the cos 2 theta to sine only, then you may use the second formula. If let's say cos only, then you may use the third formula. Okay, then come to tangent 2 theta, so we can express it as a 2 tangent theta divided by 1 minus tangent square theta. Okay, okay, so it's also in the single theta. Okay, let's move on. Okay, next one is how we change the products of sines and cosine into the sums or differences. Okay, so when you involve, let's say, what it means by changing product of sine and cosine to sums or difference. So you look at the left-hand side. So when we have a sine alpha cos beta, so this one involve a product. Sine alpha multiplied cos beta. So how we actually convert it into a sum or differences of the sine or cos. Okay, so it is equals to, okay, half times sine alpha plus beta plus sine alpha minus beta. So this is a formula. Okay, then come to cos alpha sine beta. So it will be equals to this one. And they give for the rest also. If let's say you involve the a product of 2 cos, then this is a formula. Multiplication of sine and sine alpha and sine beta, then this is the formula that you can use. Okay, so now, what it means by converting them? Okay, so we have questions about sine 4x cos 3x. Okay, can you see we involve sine and cosine? So which formula is involved sine and cosine, which is the first one, right? Which is the first one? So let me copy the first one to this. Okay, so by looking at this question, okay, so this is a formula, right? Okay, now, for the questions we have, right, sine 4x product with cos 3x. If we refer to the formula, that means the alpha is a 4x, the beta is 3x. According to what we have, it is equals to 1 over 2, then sine alpha plus beta. That means we add the two angle. So that means 4x plus 3x, then plus sine alpha minus beta, so which is 4x minus 3x. Okay, according to the formulas that we have. Okay, so now let's simplify it. Then it will be equals to sine 7x plus sine x. Okay, so that's how we convert it into sum or difference. Okay. Yes, Ilalam, the formula will be provided. Okay, just I already mentioned. Yep. Okay, so can you understand for this example? Can you understand how we convert it using the formula? So for the rest, it's actually the same idea. So I'm just taking the one of the examples, sine 4x cos 3x. Can you understand? Can you see here it's supposed to be a product, but I convert it to the sum.
Yes, miss.
Yes, okay, thank you. Okay, then next one. Okay, next one is opposite. That means how to change the sum or difference to product. Okay, so this is a formula, right? Okay, you can see there are 4 of them. And now, okay, let's look at the examples we have. Okay, we involve the sum for the sine 5 theta and sine 3 theta. So that means we should use the first one. Okay, so we should use the first one. Okay, so that means right now your alpha is the 5 theta, your beta is actually 3 theta, right? Okay, so that means sine 5 theta plus sine 3 theta will be equals to 2 sine alpha plus beta. That means 5 theta plus 3 theta divided by 2. Then cos 5 theta minus 3 theta, alpha minus beta, right? Okay, so let's simplify it. Then we have 8 theta divided by 2. Cos 5 theta minus 3 theta is 2 theta divided by 2. So which is 2 sine 4 theta cos theta. Okay, so can you see from the sum, it involve multiplication. So here you can't see the operation, but this is involve multiplication, right? Okay, okay, but you can write it without the multiplied symbol. So I'm just trying to explain. Okay, so this one involves the product. Okay, so the idea is similar. Okay, okay, so now let's move on to the angle. How we find the angle? Okay, so I think I would like to shift some of the examples up. Okay, hold on. Okay, I will go through all about the angles first. Okay, we have 30 minutes. Let's see whether we can get this done. This is about the angle. Okay. Then this is about the trigonometric identities. Okay. Okay, now, so the next part will continue for the examples that involve finding the angle, right? So before we find the angle, so you need to understand this, okay? You need to know about the whether the sign, when is a sign is positive and is a sign is negative. So this chart, okay, can you see we always present this chart as this one. Okay, so this is a first quadrant, right? Second quadrant, first quadrant 0 to 90 degrees, second quadrant 90 to 180, and third quadrant is 180 to 270, and the fourth quadrant is 270 to 360. And we always present the sign of the three quadrants in this way. So we put all for the first quadrant, then the second we put S, and the third quadrant we put T, and the fourth quadrant we put C. Okay, so and how we remember this one? What is this about? Okay, so first quadrant, when we put all, means all the sine, cos, tangent are positive in the first quadrant. Okay, so in the first quadrant, okay, for sine, cos, and tangent, they are all positive. And come to second quadrant, only sine is positive. That's why we put an S. Okay, then come to third quadrant, only tangent is positive. So that's why we put T. And for the fourth quadrant is cosine is positive. That's why we put C. Okay, so how we remember this one? Okay, so for example, you can remember it as all science teachers are crazy. Okay, so all science teachers are crazy. So I tick the initial letter. Okay, so maybe can help you to memorize it. Okay, so okay, so some students, they have others. What? Add sugar to coffee. Okay, sounds Sounds good also. Add sugar to coffee. Okay. All science teachers are crazy. Okay. Also can, whatever. Okay. As long as it can make you remember it well. Okay. Okay. So thanks for the sharing from Samuel. But this is the first time I heard add sugar to coffee. So I think some other students, maybe they have the other way to actually solve this. Okay. So now, okay. Can you see for cosine? Okay, when second quadrant sine is positive, cosine also positive. Why? Because cosecant also positive. So cosecant is actually, okay, cosecant is actually equals to 1 over sine. So since this is related to 1 over sine, so that's why when sine is positive, then cosecant will be positive as well. Okay. Okay. So for tangent, because cotangent is actually equals to 1 over tangent. That's why when come to the third quadrant, when the tangent is positive, cotangent also positive. Same goes to secant. So secant is 1 over cos. So when come to fourth quadrant, when cosine is positive, secant also positive. And of course, first quadrant all positive. Okay. Okay. So after we have a recap on this, okay, then let's look at these types of the angles. So last time we have mentioned about this also. Acute angle means between 0 to 90. Right angle is exactly 90 degree. Obtuse angle is actually more than 90, less than 180. And straight angle is 180, just for your recap, okay? And now let's move on to how we actually find the angle, okay? How we actually find the angle. So before we continue with this one, okay, let me give you another example before we come to this slide. Okay, so let's say I take another example first before I carry on with this one. Let me pick an angle. Okay, now let's say I add another question and I pick a simple one, okay? Okay, so how we find alpha equals to arc sine of 0.766? Okay, what is the alpha? Okay, what is the alpha? Okay, so of course, if you directly find arc sine, okay, you can get the angle, but you will get one angle, okay. However, can you see the requirements here? Okay, so alpha is actually again angle which is from 0 to 360. Then you have two possible answers here. Okay, so can you see when we deal with the value 0.766, right? So since 0.766 is a positive value, and remember just now, okay, as I say, okay, this is all first quadrant, second quadrant, all science teachers are crazy, right? Okay, so first quadrant all positive, second quadrant science is positive. So when we look at here, since the sign is positive, that means alpha is in quadrant, first quadrant and second quadrant. Okay, first quadrant and second quadrant. So there are two possible answers over here, right? So when we try to find arc sine of 0.766, right? Okay, when we try to find the arc sine of 0.766, what do I have? Students, what do you get? Okay. 50.13. Yeah, 50. Yeah. Okay, I get 49.996 something. So if I round it up, yes, it's a 50. Okay, so 50 degree, right? Okay, 50 degree. So now, for this 50 degree, right? If let's say it is in the first or second quadrant, okay? So in the first quadrant, this is 50, okay? In the second quadrant, this is a 50 degree, right? Okay, so remember we measure the angle from the positive x-axis. This one is a positive x-axis. We measure from the anti-clockwise, okay, anti-clockwise from the positive x-axis, then the angle will be positive, right? Okay, positive angle is measured anti-clockwise from the positive x-axis. So for the first quadrant, then your angle will be 50. Okay, your angle will be 50. Yeah? So alpha equals to 50. So this one is the first quadrant. Okay, then how about if it is fall into second quadrant? So if let's say fall into the second quadrant, we need to measure from the positive x-axis, which is from here to here. Okay, from here to here. So how we find the angle that I just put in blue? Okay, so this angle will be, okay, so this one is a quadrant number 1. Huh? Okay, so how about the second quadrant? So for second quadrant, we will take 180 degree minus 50. So 180 minus 50, okay, we get 130 degrees. So your answer is 50 degree and 130 degree. Okay, so that's how we find the angle fall into second quadrant. Okay, okay, so this is a basic one. Okay, now let's move on for some things further. Okay, so next one is actually regarding the second. Okay, second, at second, okay? Can you see this is a question? Okay, so previously I showed you about sine. So now it's at second. Okay, so for arc secant of negative 2.1499 equals to alpha, and the alpha is actually for between 0 to 360. Okay, now can you tell me secant is equals to what? One over
cos.
Yes, 1 over cos theta. Okay, that is the secant. Okay, so since we have a negative sign here, okay, so we refer to cos. So which quadrant? Okay, so remember, or as, okay, sorry. Okay, so we're referring to cos. Okay, okay, so cos is actually positive for the first and the fourth quadrant. That means cos is negative for second and third quadrant. Okay, so positive for the first and fourth, so negative for second and third quadrant. Okay, so that's why here we say second is negative for second and third quadrant. Okay, second and third quadrant, negative. Okay, so now it is negative for second and third quadrant, okay? But first, we need to find the acute angle first, the basic angle. So to find the basic angle, so what you can do is you just try to find the arcsecant of 2.1499. You just ignore the minus sign first because we want to find the basic angle. So arcsecant of 2.1499, okay? So, but our calculator, we can't find arcsecant. We can find arccos, arctangent, arcsine, right? So that means, remember this one is about 1 over cos, right? So we can write it as arccos, but the angle you have to, the value you have to write as 1 over 2.1499. Okay, so because secant is actually 1 over cos, so that's why arccos is actually 1 over 2.1499. So always remember, okay, this value you need to put the reciprocal of the values, okay, when you find the arcsecant by arccos. The same concept when go to cosecant and also cotangent, okay? Okay, so now you need to find the arccos on 1 over 2.1499 and you manage to get 62 point something. Okay, what is the answer? Okay, 62.28. Okay, the answers in the slide they put in minute. Okay, so but normally we just write it. Your calculator can convert to minute. Okay, so if we convert to degree, will be 62.28 degree. Okay, 62.28 degree. Okay, so this is a basic angle. So we get the basic angle first. Of course, if you convert to the minute, this will be the answer. Okay, now after we get the basic angle, so since we already identified it's in the second and third quadrant. So can you see this is in the second and third quadrant, right? 62.28. This one also 62.28. Okay, so the answer in second quadrant, okay, remember we always measure from the positive x-axis. So from here, the positive angle in the second quadrant will be this one. So that means we should take 180 degree minus 62.28, okay? Then we will get, okay, I think some students give me the answer already, 117.72 degree. Okay, this is the angle in the second quadrant. Okay, how about if let's say it is fall into the third quadrant. Third quadrant, if we measure from the positive x-axis, will be from here to here. Okay, so third quadrant means you should take 180 degree because from first to second quadrant already 180, then plus 62.68. So 180 plus 62.28, so which you get 242.28. Okay, so that's how we get the angle. Okay, okay, so this is the basic idea. So if you're familiar with this one, then you can understand how to solve it further. Okay, how to solve it further. Okay, so this is another example, and this time we involve cotangent. Okay. Okay, students, how about cotangent? Cotangent equals to what?
1 over tangent.
Yes, 1 over tangent, right? Okay, so when you have a cotangent of 1.3311, so this is a question. You need to find the alpha and you need to see what is the alpha given. They say between 0 to 360 degree. Okay, then again, all science teachers are crazy. Okay, so for cotangent, positive in the first quadrant and also the third quadrant. Okay, since it is involved tangent, so that means for this one is in first quadrant and third quadrant. Okay, but as I say, we find the basic angle first, right? So arc cotangent 1.311 is actually arc tangent of 1 over 1.3111, right? So as I say, because of cotangent is 1 over tangent. So when you find it as an arc tangent, don't forget to have a reciprocal of 1.3111, which is 1 over 3.11. Okay, then we find the angle, okay? Okay, so we get 37 point. I get 37.33.
I also got 37.33.
Okay, 37.33, yeah? Okay. So 37.33, okay? So in minute, if you convert to minute, will be 37 degree and 20 minutes, okay? So it's more convenient if we have this angle instead of the minute, okay? When we want to do the calculation. Huh? Okay, so now when it is in the first and third quadrant, okay, so this is 37.33. And this one also 37.33. Okay, so for the first quadrant will be very simple. So it's just 37.33. Okay, so this is the angle. But when come to third quadrant, you have to take 180. Okay, hold on. Okay. So, but when come to third quadrant, that means it's from here to here. Okay, from here to here. So we need to take 180 plus 37.33. So which is 217.33. Okay, 217.33. So that means we have two possible answers. Okay, so alpha is 37.33 in the first quadrant, and third quadrant is 217.33. Okay, I can see some students practice the calculation also. Okay, okay, so all these are the simpler one. Okay, all these are the simpler one because we just involve one trigo, right? Okay, so if you understand the one that we explained earlier, okay, then we will move on for the questions that is further, okay? So, okay, then I would like to use another slide. Okay. Okay, now, how to solve these questions? Okay, how to solve this question? Huh? Okay, so you have 8 sine square theta plus 2 sine theta minus 1. Okay, how we solve this? And they give you theta is between 0 to 360. Okay, so now, first we need to solve the 8 sine square theta plus 2 sine square minus 1. How? We can solve it by factorization, or maybe by, if can't factorize, then you have to use a quadratic formula. So solving this is actually same as 8x squared plus 2x minus 1 equals to 0. Okay, can we factorize this? Is that possible? Can we factorize this?
Yes, miss.
Okay, and then what is a factorization? First bracket. Anyone?
4x minus 1.
4x, 2, yeah.
X plus 1.
2x plus 1. Okay, so plus 4x minus 2x plus 2x. Okay, yep, correct. Okay, so when we factorize, this is what we get. So now the x is actually equals to sine theta. So from here, right, okay, if you try to factorize it, then you have 4 sine theta minus 1 times 2 sine theta plus 1 equals to 0. Okay, 4 sine theta minus 1 times 2 sine theta plus 1. So let's solve it, okay? 4 sine theta minus 1 equals to 0, or 2 sine theta plus 1 equals to 0. Okay, so 4 sine theta equals to 0 means sine theta equals to 1 over 4. Okay, so this is positive. Okay, positive values, that means this one is in the which quadrant? Okay, sine positive, which quadrant, students?
First and second.
First and second, yes. Okay, quadrant number 1 and number 2. Okay, then next one, 2 sine theta plus 1 means sine theta equals to negative 1 over 2. Okay, sine theta is negative. Okay, just how positive is first and second, negative will be third and fourth. Okay, so you need to understand which quadrant they are. Okay, now let's say we start to solve for the first one. Okay, for sine theta equals to 1 over 4. So we will try to, okay, so this is positive. So we need to find the arc sine of 1 over 4. Try to get the basic angle. Okay, arc sine of 1 over 4. What do you get? 14.4775. Okay, I see the answer. So let's say I take 2 decimal places, 14.48. Okay, 14.48. So now, for this one, right? Okay. So since this is in the first and second quadrant, okay, first quadrant means here is 14.48. Second quadrant, 14.48. Okay, first quadrant is 14.48. Second quadrant, so first quadrant, you don't need to do any calculation. Second quadrant will be from here to here. So you need to take 180 minus the angle. So what is your answers here? Okay, so your answer will be theta equals to 14.48 is the first quadrant. Second quadrant will be 180 degree minus 14.48. So 180 minus 14.48, 165.52, yes, okay. So the answer is 14.48, 165.52. Okay, now come to the second angle, sine theta equals to negative half. Okay, so we ignore the sine first. You find the arc sine of 1 over 2, the basic angle. So can you see I don't put the negative sign. So for arc sine of half, so it's actually 30 degree, right? Okay, so which is 30 degree. Okay, so that means when it is in the fourth and third quadrant, so this is 30 degree. So this is a 30 degree, third and fourth quadrant, okay? So for third quadrant, then this is the angle. Okay, this is the angle. So that means we should find the theta as 180 plus 30. Okay, this is in the third quadrant. Then how about if let's say it is in the fourth quadrant, so will be from here to here. Okay, so that means we should take 360 degree minus 30 degree. Okay, so your answer, okay, which is 210, then 360 minus 30, 330 degree. Okay, so okay, so if we try to put all the angles together, it will be 14.48, then 165.52, 210, and 330. So these are all the 4 angles. So 4 possible angles for this question. Okay, so we almost reached 4:30 already. So this is the idea, how we actually solve it, okay? Okay, is there any questions so far? Any questions you want to ask before I proceed? Okay,
Miss, just one question. For the degrees, by the way, is it a must to write it in minutes? Or can we write it in symbol?
You can just write it without limit. You just put it in the degree like how I wrote it. You can just write like this.
Okay, miss.
Okay.
Okay, thank you.
Okay. So this is the one that we discussed just now. If you understand this one, then the rest it should be okay. So actually, we still have a few other example. I still have two more examples. Okay. You can actually have a look. So I will still explain this one in the next class. Okay. But I think you get how to find, if let's say in cos square theta, like this question, I think the concept is the same as the earlier one. You just need to factorize it. If you can't factorize it, then you use a quadratic formula. Okay, so the idea to solve it is the same. Okay, so I will still explain it. Okay, then the other examples, right? Okay, the other example is when you have a different trigonometry. So I think this one I better discuss it next week. Okay. However, for what we have gone through today, you can actually practice some of the questions. Okay. For what we have gone through today, okay, maybe you, okay, since I haven't finished discussing about the questions regarding solving the trigonometry, okay, I still have two more examples. So I don't require you to do 21, but if let's say some of you want to have a try, then it's okay. Some of the questions can be done, okay? But else you can leave it first. You can actually try number 22, 23, 25, 26. This one you have to finish it. 22, 23, 25, 26. Okay, so this one definitely you should able to do it, okay, for what we have gone through today. But to find the angle, maybe you can leave it first. I still have two more examples to go. The discussions of this one is actually quite long, so we have a lot to discuss, okay? So, okay, then I think next week I will continue, I will discuss the tutorial first, the 4 questions that I mentioned. Sorry, not next week, tomorrow. Okay, tomorrow afternoon. Yeah, 4:30, so almost finished already. Okay, yeah, it's 4:30 already. Okay, then yeah, that's why I try to tell you the homework. Okay, so you have 4 questions. These 4 questions won't spend quite a long, very long time to actually solve it. If you have a problem, then it's okay. You can leave it. Then we discuss tomorrow. So I think for these 4 questions, I think tomorrow maybe we can use the first 40 minutes or 30 minutes to finish the discussion. Then I will continue for the rest of the examples, 2 more examples to find the angle. These 2 examples, I will continue to discuss it tomorrow. Then the rest is examples for trigonometry. Then we finish these topics. Okay, then maybe we can proceed to go through some of the tutorial question. Okay, then the following week, we will discuss the tutorial, then maybe do some revision for your quiz. Tomorrow, try to remind me. Okay, I try to finalize it. When is the when is the test? So for the test, right, I plan to do it after the class, not during the class. Because we have classes affected by holiday. So I plan to do it after the class, not before my during my class. So okay, but next 2 weeks timetable haven't published. I'm not sure whether there's a changes of the timetable. Oh, test is 1.5 hours. Let's say 1:30. Okay, it's okay. Let me think about it first. Okay, we need 2 hours, 1.5 hours plus 30 minutes of the submission. So 2 hours actually. Okay, doesn't matter. Yeah. Okay, we will discuss it tomorrow. Okay, after I check the schedule, then I will discuss with you about the date. Okay, then I think that's all for today. Students, okay, I will see you again tomorrow, 3:15, right? Okay. Okay, that's all.
Thank you, Miss.
Yeah, bye-bye,
Have a nice day.
students.
Bye-bye. Thank you.
Yeah, same to
Thank
you.
you, Miss. Bye.
Bye-bye.
Thank you, Miss.
Yeah,
Bye-bye.
bye-bye.
Thank you, Miss.